So what we're going to do is basically use that information to figure out what our base is. We have our input, which would be the 2, and our output, which is the 5. So we just put those numbers into our general form, and we're going to figure out what the b is. So that tells us then that 5 would have to equal log base b of 2. All right, so we need to figure out what that base is. How could we do that? Could we rewrite this somehow that might help us find the base? Right, let's put an exponential. So our base is b. Let's see, we're going from logarithmic form to its inverse form of exponential. So we're going to switch the inputs and outputs. It's going to be b to the 5th equals 2. How do we figure out what that b is then? Jack, what are we going to do to figure out what that b is?
We could graph it.
Good. Don't need to. John?
Can you take the 5th root of 2?
Definitely. Take the 5th root of 2. Just like if this was b squared, we'd square up both sides. Same idea, but now it's b to the 5th. So let's take the 5th root both sides. So the 5th root of b to the 5th is just b. And the 5th root of 2, it's not going to come out to be a whole number, so let's leave it as the 5th root of 2. So then we have our function. So f of x equals log base 5th root of 2 of x. So how do we get our calculator to graph that? And what did the minds and actions say to do? Get our calculator to graph this. So all we need to do is change the base. So what we're going to do in general terms. So to graph, we can change base. Well, if we change the base, that would give us f of x equals log, okay, let's see, what's our input? The 5th root of 2 or the x? What's the input of this function? 5th root of 2 or x? Garrett, what's the input? 5th root of 2 or x?
It's the 5th root of 2.
Oh, that's the base. That's what x. So it's going to be log of x over log of the 5th root of 2. So we can graph that. Remember, if this x was filled in with a number, you do log of the number divided by log of the original base, change the base. We're just doing general terms now with our x. So if we went to our graphing calculators, we would type that into our y equals. So I'm just going to go to y equals, and I'm going to clear out if there are any functions in there. I'm going to clear those out. And we want log of x divided by log, let's see, 5th root of 2. How do we get the 5th root of 2? Okay, so we're going to do the 5, then what? The math. And then go down to number 5 here, the x root button, because it's going to put that 5 into the roots. It's the 5th root. 2. Close parentheses. So now let's go to graph. Notice how it has the same basic shape as the ones in your book, those pictures. All logarithms have that same basic shape. graph look similar or not? So that's one way we can use our graphing calculator strategies. The other way, if you're asked to do it by hand, is like we've been doing, where we put it in exponential form and make a table, plot the points, and sketch the curve in between the points as best we can. Okay, so that's also another way to graph this.
Is it always log of x?
Think about it, Jeff. When we don't, unless the x is in the base. Because think about it, we always do log of our input divided by log of our original base and change base. So since it's x is usually our input, yes, it should be log of x divided by log of the original base. Okay. Just like if you're going to evaluate log base 2 of 10, you do log of 10 divided by log of 2. The 10 is kind of like the x, it's the big number in the logarithm. So let's see. Now, the next turn, I'm going to give you one where we're going to find the solution both algebraically, and then we're going to check it with a crack. Okay, so we're going to solve log base 8 log base 8 of n minus 3 plus log base 8 of n plus 4 equals 1. So these, like the problems we've been working on, we have two logarithms on the left side that we're adding together. So how could we rewrite that as the logarithm of one thing? Right, exactly. Write it as log base 8 of n minus 3 times n plus 4. So let's do that. So we rewrite it as log base 8 of n minus 3 times n plus 4 equals 1. Okay, so now our variables, the input of an exponential function, excuse me, the input of a logarithmic function. So let's rewrite it in exponential form. So our base is 8. 8 to the first, we're switching our inputs and outputs, equals n minus 3 times n plus 4. So in going, we're using our inverse property, so we're switching our inputs and outputs. Then all we need to do is simplify it and solve it. So we get 8 equals, let's see, n squared, distribute the n, first n here. So n squared plus 4n minus 3n minus 12. So let's see, we want to make one side equal 0. We have 0 equals n squared plus n minus 20. Right. Combine the 4n and the negative 3n and subtract 8 from both sides. So now what can we do to solve this one? Quadratic. What's even easier than the quadratic? Factor. This one will factor pretty quickly. You can go to the quadratic. It's just if you can factor, a lot of times that's a little perfect here. So we can have 0 equals, say it again. Okay, positive 5 and negative n plus 5 and n minus 4. Okay, so then we have, okay, that means 0 equals n plus 5, or 0 equals n minus 4. So negative 5 equals n, or 4 equals n. What else do we need to do? Right, we need to put it back in, make sure it works. Are there either of these base 8